Let's continue on to section 1.2. We're going to keep building our vocabulary here. Now, first thing is we're going to use two definitions for the word statistics. First of all, as we talked about in the previous section, statistics is a science where we use data to make decisions. And so that is, the subject name is statistics, but first of all we have a parameter, and a parameter is a measurement of some characteristics of the population. So population parameter. As we talked about in the previous lecture, is when we gather data about the entire population. That process is called a census, but the data that we collect are parameters. Gathering data about an entire population is expensive both in time and in money. So many times we don't know parameters, we can only estimate them, and we use statistics from a sample to estimate those. So when we take a subset of the population, that's a sample. The data that we gather from that sample is a statistic. We use statistics to estimate parameters, and that's the process that we're going to talk about in most of the course. So the whole thing is the population, and data about the population are called parameters. When we take a subset of the population, that's a sample, and the data is a statistic. So statistics is the process of using sample data to make estimates about population data. So a statistic is data we derive from a sample. Now we have different kinds of data. The first one is quantitative, and quantitative is a quantity, or it's numerical data. So it consists of numbers representing counts or measurements. And you've got two examples. These happen to be from the textbook, I believe, talking about the example of a quantitative measurement. Your age is quantitative. Your height is quantitative. We would measure that with numbers. The number of miles you drive per year is quantitative. Then there's categorical or qualitative, and categorical looks at some attribute, and we do names or labels representing those categories. For instance, the color of your eyes would be a category. What is the model of car that you drive? What is the type of vehicle you drive? Those would all be categorical. Whether you drive an SUV, a pickup, a full-size car, a mid-size car, a compact car, a subcompact car. Those would be categories. Now, we need to be careful because sometimes numbers substitute for names. For example, on a sports team, the numbers on the jerseys substitute for the names. Now, quantitative data with numbers, can be divided into two parts. One is continuous and one is discrete. One comes from counting, and so there's only so many there can be, and the other one comes from there are many places in between. If we're looking at decimal numbers, there are many decimal numbers between two whole numbers. So discrete data comes from countable. So when we talk about chickens and the number of eggs that the hen lays, a hen can only lay whole numbers of eggs. 2 or 3 or 4 eggs. A hen cannot lay, one hen cannot lay 2.76 eggs. So that would be discrete data. How many classes are you taking? You're taking 2 classes or 3 classes. You're not taking a class and a half. Then continuous data results from many possible values that come between the values. So for instance, if we look at the amount of milk that a cow produces, we can take that out to an infinite number of decimal places. Your grade point average. There are many possibilities between 2 and 3 and 4. Your income would, you don't just make $1,000 or $2,000. There's all kinds of things in between that you're going to make. So continuous means there's an infinite number of possible values. Again, with the grammar alert. When you have discrete amounts, you use fewer. So I drank fewer cans of pop this week. The hens laid fewer eggs this week. When you have a continuous amount, you use less. So since I drank fewer cans of pop this week, I drank less pop this week. The cows gave less milk this week. I made less money this week. Then we look at levels of measurements, and we're going to talk about 4 of them. The nominal level of measurement. Nominal comes from a Greek word that means name, and so names, labels, or categories. The data cannot be arranged in an order, such as low to high. So it's yes, no, undecided. That's just how it is. Which cola do you prefer? Coke, Pepsi, Royal Crown. Then there's the ordinal level of measurement that again, they're arranged, they're a label, but they can be arranged in an order. So for instance, we know that an A is better than an F when we talk about course grades. When we're running a race, we know first is better than second is better than third, etc. But I can't say that second place is twice as good as first place. It doesn't make sense. Now, on page 17 in your book, there is a sidebar that talks about measuring disobedience, talks about the Milgram experience, which is a very interesting experience. So this is a live link to that experiment. It's about 10 minutes. It's very interesting if you have the time to look at that. Then there's the interval level of measurement. We can look between the difference between the data points, but there's no natural zero. So when we're talking about the year, we know that from the year 1000 to the year 2000 that there was 1,000 years have passed, but we cannot say where the year 0 is. It doesn't mean there wasn't any time, because we have BC years and we have AD years. So there is 0 doesn't make sense when we're talking about time. Now temperature is kind of in this spot unless we're talking about the Kelvin scale. But let's talk about Fahrenheit that we're most familiar with. When we have 0 degrees, that doesn't mean there is no heat left. In fact, we can go below 0. So that would be the Fahrenheit temperature scale, and the Celsius temperature scale for that matter would be an interval level of measurement. Now the ratio level of measurement also has to do with numbers, but there is a 0 that is meaningful. So for instance, If your college textbook costs nothing, then it represents no cost. But we also know that a $100 book costs twice as much as a $50 book. So let's summarize those. Nominal is categories only. Ordinal is categories with some order. Interval usually deals with numbers, but there are differences but no natural starting point. And ratio is we can find the differences between the numbers, but there is a natural starting point. Some new things in this edition of the book: it talks about big data. We deal with big data all the time. In your book, it talks about Edward Snowden. It talks about using big data instead of clinical trials to do drug testing. So big data requires a lot of analysis power, so we might need to use many computers to analyze big data. And then data science looks at that. In some data sets we have missing value. Sometimes the data values are missing completely at random, in that any piece of data is just as likely to be missing as any other piece. And then there are data values that are missing not at random. For instance, in my research, I looked at data that was gathered at orientation at Iowa State, and one of the issues was ethnicity. Some people chose to put none. Some people didn't answer that question because they didn't want to. That data value was missing, and when I analyzed the data and I was looking at relationships between ethnicity, I had to eliminate those individuals in that analysis. So what do? We can delete cases, which I just told you about, or we can impute when we substitute values for that missing data. The science of doing that is beyond the realm of this course. If you go on to do any big studies, you may have to get advice from a statistician what to do with your missing values. Now would be a good time to do my math lab homework for section 1.2.